In this video, we're going to cover the content for the oxygen consumption lab. In my personal opinion, the oxygen consumption lab is one of the most important labs that we'll do all semester. The reason is oxygen consumption is, in my view, the most important topic that we'll cover as it relates to exercise physiology. Most people, when they think of exercise physiology, they think of the term VO2 max. And that's exactly what we're going to talk about and learn about today is oxygen consumption, otherwise known as VO2. Before we get into oxygen consumption, let's kind of review and understand a little bit about the basics of metabolism that must happen in order for energy to be produced. So as the slide kind of shows you that there is an essential role of ATP in exercise. In order for force to be developed, if you'll remember, back in the very first lab we talked about exercise is defined as muscle contractions. In the second lab, we then defined muscle contraction as the active development of force. And we defined active meaning that it requires ATP. And so here we see this definition now come into fruition for metabolism by saying in order to generate force, we must directly use ATP. Indeed, the metabolic process in which this occurs is ATP hydrolysis. I'll note you don't have to know the specific reaction, but the key is there's no other option in order to provide energy. Everything that we do in a muscle contraction requires ATP and ATP only. So in this reaction, as we go through, reminding you about what's going on in lectures, this is an exergonic reaction. We have a hydrolysis reaction, hydro meaning water, so we're going to use water to break the bond of an inorganic phosphate in ATP, release energy, and we're left with ADP and an inorganic phosphate. This energy then can be used to do work such as a power stroke in a muscle contraction. Of course, it makes sense though as we exercise that this is continual muscle contractions, and therefore we must have a continual supply of ATP for muscle contractions. And that's where metabolism comes in. Remember, from lab we talk about energy metabolism or bioenergetics are the pathways that provide energy. And so we've learned that there are numerous pathways in this that are able to provide energy. We learned about two primary pathways, and we'll show them up on the screen, is aerobic and anaerobic metabolism. Again, we'll quickly define those to make sure that you're caught up with what's going on in the lecture part of the class. So anaerobic metabolism, the preferred definition that I like to use is that it is independent of oxygen. So if you want, you can add that here. You can define anaerobic metabolism. It tells us that it is independent of oxygen. In other words, the other way to think about it is oxygen is not required for the production of energy. The two dots here represent that we can think about this system has a pro and a con to it. The pro to anaerobic metabolism is that it is able to provide energy extremely rapidly. Again, the pro to anaerobic metabolism is it is able to provide energy very rapidly. The con of anaerobic metabolism is that it only provides a small amount or a limited amount of ATP. Again, the con of anaerobic metabolism is that it provides only a small or limited amount of energy. So it's fast, but a small amount of energy. If we look at our other pathways of energy, we can look at aerobic or oxidative metabolism. Oxidative being that kind of key word that again indicates that aerobic metabolism requires oxygen for the production of ATP. So again, aerobic metabolism can be simply defined or thought of as requires oxygen for the production of ATP. It has a pro and a con that I'm going to list here. Obviously there's more than this, but this is the way that this is what you need to know as we're kind of moving forward in the lab. The pro of aerobic metabolism is it produces a large amount of ATP. Very large. Indeed, if we kind of think back, we can think to the numbers in lecture that we're learning. So 32 ATP for completely oxidizing a molecule of glucose, whereas anaerobic metabolism, 1 in PCR, 2 in glycolysis. So a very large amount of ATP. So again, the pro for aerobic metabolism. is that we generate a large amount of ATP. The con of aerobic metabolism is that it is slow to get going and slow in its production. So it can't produce ATP at a really fast rate. Again, I'll kind of reiterate. The con is that it is slow and can't produce ATP at a rapid rate. Hopefully you see that there is a pattern between these two, in that the pro and cons are exactly opposite, right? Aerobic, a lot of ATP. Anaerobic, not very much. Anaerobic, very fast. Aerobic, slow. And so hopefully as we move forward as a class, you can kind of start to see that these systems are going to work together to help you understand how we provide energy for muscle contractions during exercise. These two don't work opposite of each other. Indeed, they work together as we go through. Today, in lab, we're going to focus on aerobic or oxidative metabolism, and anaerobic metabolism will be after the midterm.